Good morning to all of you. Now I'm going to prove one more function is an even function. First of all, so we have to make it free from modulus function. I mean modulus integral part. Here a given function contains modulus as well as integral part. So using the properties, so make it free from modulus as well as integral part. So in order to do that, I'm going to simplify first of all ln of e power x. Here ln of e power x is nothing but natural logarithm. So for natural logarithms, so base is to be taken as e. So log of e power x to the base e. So it is of the form log of a power m, which is nothing but m into log a. So obviously here log of a power m to the base e. What is the formula for it? M times of log a to the base. So even this x times of log e to the base. What is the value of log e to the base e? 1. Hence ln of e power x value is x. Similarly, integral part of 2 plus x plus integral part of 2 minus x. What about this function? Okay. Now, how can we do this? For that, you should get to know this property. Integral part of x plus n is equal to integral part of x plus n if n is any integer. If n is any integer, then integral part of x plus n can be written as integral part of x plus n. Here x can be any real number. For all x belongs to R, integral part of x plus n can be written as integral part of x plus n. Here n can be any integer. Now I am going to apply the same property here. Now what about second function? Integral part of 2 plus x plus integral part of 2 minus x. So it can be written as 2 plus integral part of x. Why? Because 2 is integer. Even here 2 plus of integral part of minus x. 2 plus 2 how much? 4 plus integral part of x plus integral part of minus x. Similarly, I am going to simplify third function. E power ln of x. That means e power log of x to the base. Since exponential and logarithmic bases are equal, obviously it is x. Now I am going to redefine the function. What is the domain of given function? In fact, what is its domain? Here domain of given function is, here it is defined for x less than or equal to minus 1 as well as minus 1 to 1, x greater than or equal to 1. So how can we write this? Union of minus infinity comma minus 1. Open interval, left to open, right closed interval of minus infinity comma minus 1, union, open interval minus 1 comma 1, union. Similarly, it is defined as e power ln of x when x greater than or equal to 1, right? So, union left close, right open interval of 1 comma infinity. Obviously, this is a set of real numbers. Open interval minus infinity comma infinity. That is set of real numbers. So, domain of given function is nothing but union of all these three intervals. So, x less than or equal to minus 1, minus 1 less than x less than 1, x greater than or equal to 1. Okay, now I am going to redefine the function for the same real values of x. Now f of x can be written as, what about the first function? Therefore f of x is equal to, now the first function is mod of ln of e power x. So what is its value? X. Then obviously it is mod x. is equal to, here it is defined for all values of x which are less than or equal to minus 1. The values which are less than minus 1 are all negative. Hence mod x can be written as minus x. What about the second function? It's a simplified function is this 4 plus integral part of x plus integral part of minus x for minus 1 less than x less than 1. Similarly, third function obviously x for x greater than or equal to 1. This is f of x. Now I am going to simplify it further. What is the property here? Integral part of x plus integral part of minus x. Now we have to make it free from this integral part. How can we remove these square brackets? So I am going to use this property. Let us use this property. Is equal to 0 if x is an integer and is equal to minus 1 when x is a non-integer. So obviously in between minus 1 and 1, so there is one and only one integer 0. That is what? So we have to break this interval at 0. Now how can we write the same function? F of x is equal to, obviously first function is same, minus x for x less than or equal to minus 1. I am going to break this interval at 0. Why? Because so here at x is equal to 0, integral part of x plus integral part of minus x is 0. Why? Because 0 is an integer. Now for all other values of x, obviously it is a non-integer. So I am going to break this interval. Minus 1 less than x less than 0. X is equal to 0 as well as 0 less than x less than 1. Okay. So break this interval at 0. Now each and every real number between minus 1 and 0 is non-integer. So obviously 4 plus, what is the value of 4 plus integral part of x plus integral part of minus x? 4 plus, its value is minus 1. Why? Because x is a non-integer. Here between minus 1 and 0, all the real numbers are non-integers. So 4 plus of minus 1, its value is 3. Next, if x is equal to 0, since 0 is an integer, it can be written as 4 plus, what is the value of integral part of x plus integral part of minus x? 0. So it is 4. Similarly, between 0 and 1, all the real numbers are non-integers. Again, we have to define it as 4 plus integral part of x plus integral part of minus x is minus 1. 4 minus 1, how much? 3. Similarly, last case. What is the last case? Whenever x greater than or equal to 1, it is x. Now I am going to draw the graph of this function. So even function is always symmetric about y-axis. Now look at the graph. Now for x less than or equal to 1, it is less than or equal to minus 1, it is defined as minus x. So I am going to take minus 1, minus 2 and so on. Similarly this side 1, 2, 1, 2, 3. This is 4. Now even below x-axis, this is x-axis and y-axis. Okay, for x less than or equal to minus 1, it is defined as minus x. So put x is equal to minus 1 in it. Now what about the first function? It becomes minus of minus 1. How much? 1. So for x is equal to minus 1, it is defined as 1. Similarly for x is equal to minus 2. So I have chosen another value which is left of minus 1. Let's say minus 2. So it is defined as minus x. Minus of minus 2 how much? Plus 2. So for minus 2 corresponding image is plus 2. Now this graph looks like this. Okay, this is a graph of minus x. Whenever x is less than or equal to minus 1, it goes like this. Similarly, between minus 1 and 0, obviously it is 3. Minus 1 to 0, it is 3. It's a constant function. Similarly, at x is equal to 0, it is defined as 4. At x is equal to 0, it is defined as 4, this point. Next, again between 0 and 1, it is defined as 3. It is also a constant function. So here endpoints are not included. So it is broken at 0. Okay. So this is 4. Now this point is included. At origin it is 4. Next, for x greater than or equal to 1, how can you draw the graph of h? Here f of x is defined as x when x greater than or equal to 1. That means for x is equal to 1 it is 1. For x is equal to 2 it is 2. For x is equal to 3 it is 3. So on. It looks like this. Now once look at this, obviously it is symmetric about y-axis. So here the y-axis is the axis of symmetry. Here y-axis is the axis of symmetry. So even function is always symmetric about y-axis. So if we fold the graph along y-axis, obviously both the graphs, right of y-axis, left of y-axis, both the graphs will coincide. So hence it is an even function. So by the graph we can say that it is an even function. F of x is even. It is an even function. Why? Because it is symmetric about y-axis. So thank you very much. So I am going to end this. Have an awesome day.